Hello, Integrated Math 3 and Integrated Math 3 Plus. Welcome to lesson 10-4. So far you've spent enough time in algebra now and solving equations now to know that pretty much every function has an undo button, all right? Every single function family has a way to undo, has an inverse function family. You've been noticing that, and we've been playing with this with graphs, with tables, with algebra, with geometry. Just like when you learned back in the day when you were young in elementary school, you learned that you could undo addition by subtracting. You learned that you could undo multiplication by dividing. None of these things are new to you. And so just like all of that, of course, you are now noticing that we can undo a square root by squaring it. So can we talk about this geometrically for just a minute or two here? By the way, we're still on student activity sheet number 4, if you're not sure where we've gone off to. And we are on question number 3. In case you don't know where we are, that's where we are. I got to get to there. Oh my goodness, there we are. We're on question number 3, which we'll deal with in just a minute. But before I have you solve question number 3, can we just real quick, can we talk about what happens geometrically when you square a number in algebra tiles? So here I have a number 3, and that means I got 1, 2, 3, 1, 2, 3. And when I square that 3, I literally create a square of tiles. 3 squared, 3 times 3 gives me 9, all of that good stuff. You just got to be super careful because there's a little issue here. It's this thing called the principle of powers. And it states that for any positive integer n, if I have some number a and it's equal to b, then I know that a to the n power should equal b to the n power. When I raise both sides of an equation to an even power, then I get the same answer. The resulting equation should have the same solution. However, just because a to the n equals b to the n is true doesn't mean it's always true the other way. That doesn't necessarily mean that a equals b. Like, for example, you know that negative 3 squared is 9. You also know that 3 squared is 9. But you also know that negative 3 does not equal 3. They are not the same. So you really need to make sure that you check all possible solutions for accuracy using the original equation. Remember extraneous solutions when we did our rational equations? Yeah, guys, we can have extraneous roots as well in our square root and cube root equations. So do the math, do the work, but make sure that you double check it, that you plug into the original to check for extraneous solutions. So this takes us to question number 3. And your question number 3 looks a little something like this. It says to solve the equation, and you have, real quick, you have x plus 3 squared. You have x plus 3 squared, and it equals 25. I would like you to take just a few moments to go ahead and solve for x. You know how to do this. Hit pause to work this out. Hit play when you're ready to check your work. All right, guys, so I did the work. This was the problem you were working on. So the first thing I noticed is that there was a square there, and I could have done x squared plus 6x plus 9, but I thought, you know what? I could do a square root to get rid of that. And if you do the square root on one side, you've got to do it to the other. The only thing is when you do this, and I'm going to come back here and write it out to show you, when you do that square root, when you do the square root, I'm going to bring that up here. There we go, the square root of one side and do the square root of the other. What you want to keep in mind is what we were just talking about. So while there is an x plus 3, this means you could either get x plus 3 equals 5, or you could actually get x plus 3 equals a negative 5. Because, yeah, 5 squared would give me 25, but negative 5 squared would also give me 25. And this means I actually have two solutions. And if I subtract 3 from both sides, I get x equals 2. And over here, if I subtract 3 from both sides, I get x equals a negative 8. So I actually have two solutions here. It's always important to plug back in and double check, but I believe in this particular case, if you plug back in and double check, it does work. And I'm going to bring my arrow back, sorry. It does work for both problems. If I plug in a 2, I get a 5. 5 squared is 25. If I plug in a -8, I get a -5 squared, which is still 25. So in this case, both of them worked. But it's super important to make sure that you plug into the original equation in order to make sure things work, because we know that -5 is not the same thing as 5. Oh, I have to erase this, don't I? Go away. Go away. Because we know that -3 is not the same thing as 3, and you've just got to be super careful now. We know now that we can do all the right work and still get answers that don't make sense, that don't work for the original, those extraneous solutions or extraneous roots. So here's what I would like you to do. We're going to go over to question number 4. And we're going to solve this a few different ways. We're going to work this out. Now, of course, we're always going to double check our stuff algebraically. So the first thing I did on question number 4 is I graphed it. And you might want to make a note of this. You have this graph on your paper. It's off to the side there. But I went ahead and graphed it. I said, okay, y sub 1 equals root x plus x. For that's the one side. So I graphed that guy. Ooh, he's the one in red. And then y equals 2. So I graphed that guy in blue using Desmos. And because I graphed that side of the equation, that side of the equation. And I can see I have one solution. It's right there. I've got one solution at x equals 1. This is my first graph. However, I can manipulate this a bit. And I'm going to manipulate this a bit. I'm going to go ahead and subtract x on both sides. Boom. Which means I actually end up with a square root of x equals 2 minus x. And I can graph y equals root x, that's this guy in red right here, and I can graph y equals 2 minus x, and that's this guy right here. And again, I can see they hit in exactly one spot at x equals 1. I'm still getting x equals 1 as my solution. But remember how I said you got to be careful? You got to be careful. The second graph on your paper happens if I get rid of my square root by squaring both sides. So I'm going to go ahead and square both sides. So that becomes an x. And if I square the right side, that becomes 2 minus x times 2 minus x, which if I multiply it together, gives me 4 minus 4x plus x squared. And you'll notice this is the graph you have on your paper, so hopefully you got that work in there. So I graphed y equals x, and I graphed y equals 4 minus 4x plus x squared. And now you'll notice I now have two solutions. I have a solution at x equals 1, and I have a solution at x equals 4. I could even take this further. If we wanted to solve this algebraically, you've got one last graph down there. I could set it equal to 0. Usually when I solve quadratics, I set it equal to 0, right? So I'm going to set that equal to 0. I'm going to subtract x on both sides. So that gives me 0 over there, which is what I wanted. And if I combine these, a negative 4x minus x makes that a negative 5x. And if I graph that, I now have y equals 0 on the one side, but I also have y equals 4 minus 5x plus x squared, which factors 1 minus x times 4 minus x. So I have an answer at x equals 1 and an answer at x equals 4. And the graph now looks like this. And again, I've got two solutions at x equals 1 and x equals 4. I have two solutions now. So what is going on? The first original time we graphed it, we only had one solution, and now I have two? So this is why I'm telling you, you've got to plug back into the original and double check it. So let's keep going with question 4. I'm going to plug these in and double check. So I'm going to plug in a 1 to the original equation. So it's the square root of 1 plus 1, and the square root of 1 is 1, and 1 plus 1 is 2, which is what we wanted to be equal to. Yay. So x equals 1 is an actual solution. That one's good. But remember how as we started working through the algebra, we got a second solution coming up. So I'm going to plug in that 4 to the original. So now I have the square root of 4 plus 4. And of course, we know the square root of 4 is 2. And 2 plus 4 is 6. Is definitely not 2. So this means that x equals 4 is not a solution. It's an extraneous root. It's not an actual solution. This is why, guys, you've got to double check. And this happened because we squared both sides. Remember what we were saying earlier in the lesson that negative 3 squared does give me 9 and 3 squared gives me 9. But negative 3 is not equal to 3. We know this. So that's why you can get an extra solution, an extraneous root, when you square both sides. That's why it's so important to make sure that when you work through the algebra, you don't always have Desmos in front of you. You don't always have a graph in front of you to see what's going on. That's why it's so important that when you work through the algebra, which you guys know how to do, you've got to make sure you go back to the original equation, plug it in, and double check it. They don't always work. Squaring it sometimes brings in extra solutions that we don't want. So yeah, there's only one actual solution. It's x equals 1. Please make sure you plug back in and double check. So with this in mind, I would like you to go to question number 5. All right, 5A. We'll start with 5A. 5B I will torture you with in just a few, but can you start with 5A? Go ahead, work it out, do all the work, but make sure you plug back in to double check your answer. And then when you come back to me, we will check it graphically. So go ahead and pause to work this out and hit play when you're ready to check your work. All right, so the first thing I did is I added x to both sides. I wanted to get my square root all alone. So I went ahead and added x to both sides. So I got square root of x minus 3 equals x minus 5. And then I squared both sides. So I got x minus 3. And then x minus 5 squared gave me x squared minus 10x plus 25. Because remember, it's x minus 5 times x minus 5. And then I moved everybody to the same side. So if I subtract x, it gives me a negative 11x. If I add 3, that gives me a 28, and now it's set equal to 0. This, you could use a quadratic formula to solve it, but personally, I like to factor whenever I can. So I factored it, and I got x minus 7 times x minus 4. So I got 2 solutions. Please plug it back into the original and double check it. So I plugged in a 7. So I got 7 root 7 minus 3 minus 7. 7 minus 3 is 4. Square root of 4 is 2. 2 minus 7 does give me a negative 5. X equals 7 is good. But we said our other solution was a 4. So 4 minus 3 is 1. Square root of 1 is 1. 1 minus 4 is a negative 3. It is definitely not negative 5. So x equals 7 is a solution, and x equals 4 is extraneous, and it's not a solution. If you graphed the original, so if I graphed y equals root x minus 3 minus 5x, and if I graphed y equals negative 5, I would see, hey, they only actually intersect once. So this is what I mean. It's so important that you plug back in and double check, double check, double check. Try out 5B. I would, if I were you, I would get, again, my square root of x minus 3 alone. I would subtract this to the other side, start off with that. It's going to get messy, but remember that we still love you. Go ahead and hit pause to see if you can work your way through this, and then hit play when you're ready to double check your work. All right, people. So I got my root x minus 3 alone. So I subtracted that root x plus 2. And again, square both sides so that that radical goes away and I have x minus 3. But when I squared this side, got ugly. So I squared this side, and I got 25 minus 10 times the square root of x plus 2 plus x plus 2. Oh my gosh, I combined some like terms. I knew 25 plus 2 is 27, and I just moved the x out front. I'm going to subtract x and subtract 27. And you'll notice that the x's die, and negative 3 minus 27 equals negative 30. I still have that negative 10x plus root x plus 2, so I divided by negative 10, and I got a 3. Already, this looks much, much better. That was horrible. I'm sorry for that horribleness, but now look how nice this is. I'm going to square both sides. 3 squared is 9. If I square this side, I get x plus 2, subtract 2, and I get x equals 7. I hope you remember to double check. I only got one answer this time. I got a 7, so I'm going to go back to the original equation, this guy way up the top, and I'm going to plug in my 7. So 7 minus 3 is 7 plus 2. 7 minus 3 is 4. 7 plus 2 is 9. Square root of 4 is 2. Square root of 9 is 3. That does equal 5. Thank goodness that one worked out okay. So x equals 7 is a solution. You've got to plug it into the original and double check it, people. Of course, you could graph it as well if you wanted to double check it. Also, we could come over here to Desmos, and I could be like, hey, Desmos, I want to do the square root of x minus 3 plus, and the square root, what was that? I got to see it. Square root of x plus 2, x plus 2, oopsie. Try that again. Come back. Square root of x plus 2. I probably should put a y equals out in front of it. I mean, it's clearly already doing it, but still, I'm going to be a good girl. And then, of course, that means for my other side, I'm going to do y equals 5. So y equals 5. And boom, there it is. You can see it hits right where x equals 7. Yay. So it's always nice to be able to double check your stuff on Desmos. Let's head over to